interruptive. As usual, we have to sort of sit around for 20-30 seconds and let all of the adverts finish playing. It makes the YouTube VODs very boring. But hello and welcome to everybody that's already here. And I can see that Saladin's already here and Danny Cron's already here. And we've got somebody I don't recognise. Draco0x191. Blimey says hello, just hello. Oh, and we've got some chats going on the Discord as well, so I have to look at several different chats to make sure I'm keeping up with things. Yes, well, it's another Tuesday. Hasn't it gone quick? We've decided on the Discord that we're not calling these Tuesdays anymore. These are now CodeZone days. That's how we pronounce that day of the week. So Tuesday is so last week. Now it's CodeZone day. And we've got Standard Int has arrived. Hello. Apostolisk has arrived. Hello. James Franco. Hello. Slice is here with his groovy cat. Not much time to get in here. No, it was a pretty short notice this time. To be honest, my tea overran. Tea in England isn't sitting down with a cake and a cup of tea. It's what we call our evening meals. So what are we doing today? That's an excellent question. Well, today I thought we would start by just addressing this sort of little fuzzy issue around the end. Now, I can't remember who it was, I apologise, but we implemented the suggestion of just making this a bit larger than the disk in the background. And, well, I liked that idea, but what we need to do is break this edge. So we might just delve into the art software and try and remember how to break the edge of this image. Might just be easier to draw a new image, we should see. I thought evening meals in the UK were just cake and tea, though. Well, yeah, there's some truth to that, Danderstein, yes. Hey, Alex, how are we doing? Good, good, good. Actually arrived on time. Ericsson, yes, well done. Well, we might not be doing too much maths, although I will point out I have added to the code in our stuff to do file Ericsson's smooth camera. Now, I had some thoughts about it. Which doesn't mean we can't use it, but we do need to think about what we're going to be doing with camera lerp time. So Ericsson, later after the show, I think, he came up with a nice bit of code to do a what's called a linear interpolation between the planets. Now, we kind of did that anyway, but ours was never sort of satisfied. It was always chasing the planets. Now, that might be a good thing, it might be a bad thing, but nonetheless, it was an easy, quick way to do it. So Ericsson provided this method instead. I just missed my bench, though, when I was leaning on my elbow. Ericsson's provided this different approach, which is we actually interpolate time instead between the two locations, and the final location always happens to be the target of where the planet is. And he demonstrated it with his fractals, of course, because it's Ericsson and everything's fractals. And it does look quite smooth. So we might get around to implementing that later on. Everything's apparently trivial in a shader when it comes to Magetsub. What about second breakfast? Well, indeed, what about it? What about 11ses and brunch? Well, I do know about those too. Dragon Eye, hello. Twowsers. I'm not going to say that again. And Draco, the Mighty Ericsson math. Yeah, well, Mighty Ericsson math has let us down, I think, 4 out of 5 times so far. But, you know, he always comes through in the end. Marseille32M, hello. Speedy, hello. Good to see you, Speedy. I think I missed the hello last time, but I always like to see Speedy in the chat. Plush Amazoni, aloha. Yes, I'm going to definitely have to be careful saying some of these things. Beef Viper, NanoX here. The Chazeg, yeah, quite a few people rocking up already. That's good, that's good. But let's try and do some actual coding. Well, some artwork to begin with, because what I want to do is look at what we're doing for the sky here. And I'm going to take the idea a bit further. I'm going to blur the edges. So it's not going to be code straight away. But I just need to try and remember the original image. We'll have a look at this image later. But the image I'm after is Star Sky, this one here. Well, that doesn't help, does it? That's a bad start. Let's drag that to somewhere else over there. Does that open it as a separate file? There we go. Good. Let me just... I mean, that's nice and artistic in its own way. It reminds me of the moon last night. It's very large in the UK at the moment, the moon. It's particularly on the horizon. So here is the original circle image. Now, don't tell me this is all one image. Oh, it is. I don't think I've got the original source image for this. So, I want to break the edges of it. Oh dear. Now, I have to use the masking tools. And just like in Photoshop, I've no idea how the masking tools actually sensibly work. Let's first of all, let's get ourselves a circular, an elliptical marquee. I'm going to stick the grid on because I think the grid... Well, that grid's no good, is it? That's rubbish. How many pixels is this? This is 2048, so let me adjust my grid settings. We can find sort of the middle of the image quite easily then. Grid and axis manager. Show a grid. No, we don't want those spacings. We want basic. Every 64 pixels. Yeah, that'll do. Right, that's fine. So now we can at least identify the middle of the image, which is about there. And so hopefully I can draw a circular marker. This, I'm guessing, on the stream just looks like a white rectangle, right? So maybe I can actually put a background layer in. New layer. Swap those around, and we'll just fill this one. There we go. So you can actually see a bit better than I can. That's nice. Right, so let's try and work out how to do this. So we got Photoshop experts, well, or Affinity experts. I want to create a selection. Firstly, I don't think I can grow one out like this, can I? Drag and shift to constrain. Oh yes, see, that's the problem, right? It does it, always does it like that. It can't do it just from the center, I don't think. No, it's not like Photoshop in that regard. So I'll have to. But I can see where the edges, now I've put my grid lines in, I can see where I need to start dragging my circle. And I'm going to start dragging one tile in, because that's the edge we're going to break. So if I go from there to there, I want to say there. Yeah. So that's approximately radially symmetrical. There we go. I appreciate right now it's probably difficult to see on the stream, but it is a dotted line there. And this is the bit that I always get wrong. So what I want to do is select the inverse of that. Invert pixel selection. So I've now sort of selected the black empty space and the fringe of my planet here. And I want to, I want to sort of radially destroy that in a way. So is there, maybe I need a different layer or something. Maybe, what are these masking layers? Let's try that. Maybe select all the alpha and invert the selection. Well, yeah, I could just do like a feather. Blur could be a way to do it, actually. We could try blur. I was going to try and do it using sort of an automatic gradient that just fades it out. But let's try it with a blur. Why not? Because I can choose specifically a radial blur. Yeah, you see, that's no, it's not radial blur that I want. Is it? What is the? I want to. Is it zoom blur or something like that they call it? New adjustment layer. Sorry, filters. Blur. Zoom blur. Right. Okay. Ooh, yes. Right, but is that a bit harsh still? You have to go at 9 PM. Got another hour till Aldi closes. Yeah, that's a nice blur. That, yeah, it's a good call. That was probably Magetsu. He knows about these things. So that's a nice one to use. I'm still thinking, is that just a bit harsh? And do I want to break that edge? Yeah, maybe I do. But anyway, we can try these things and see what happens. So I'm going to click apply there. And now I'm going to get rid of the background, because make it so you can't see it again. And then I'm going to export this image as our star sky. Export there. And I want to put this in the project folder, which is E drive space thing, assets, space thing, assets. What I'm going to do is actually save this as star sky, but with flare, because I may end up using both, maybe. We'll see. Star sky with flare. Right, save. And now let's load that in. Let's see what that looks like. So, where are we going? It was under star, wasn't it? Yes, we created a specific type. Star sky flare. And we drew it just a little bit bigger. Now, I'm not going to change the size just yet. Let's just see what that looks like. Maybe a lens distortion on the whole star. Ah, yeah, we didn't do sort of the spherical distortion, did we? Okay, let's take off the locked camera mode. And it is moving sort of very slowly. Everything's moving very slowly, so we can see that the textures are doing their thing. But yeah, a bit harsher than I want. So I think we want to make it still just a bit bigger than it is. So we increased it by 1%. I'm going to try increasing it by 5%. Maybe that's far too big, but we'll see. This is the fun side of game dev, right? This is the bit that I actually like, sort of tweaking this sort of thing. Yeah, that looks okay. It's still a bit harsh, right? Maybe there's not enough interference going on around the edges, because it blurred it, but it didn't necessarily sort of fade it out. Now, we talked a little bit last week about game scale, and realistically, the scale I'm thinking the sun will be at as we're traveling across it is going to be like this anyway. Like your ship is going to be microscopic in comparison. So, other than on maps and things, you'll never actually see the size of the sun, the whole thing at once. What if you made one at 100% and one at 105%? I think that's what I've just done, isn't it? Oh no, okay. So what was the first one? The first was the... yeah, both of these are clouds. Okay, that makes sense. I'll keep that one at 101%. I do like having a little bit of a harsh edge there. Oh yeah, that's nice actually. That's sort of it's just feathered it a little bit, but you can still see there's a distinct second ring sort of in there. But no, we can live with that. I'm going to just speed up time just a touch, because what I want to see is how much are they interfering with each other. Maybe we can tweak the blur and things later on. Now, to speed up time for my planets, my celestial body was my basic thing. Here we go. It was speeding up time. I have total time. I'm just going to totally bodge this for the time being. Times that by 1.5. Let's times it by 10.5. Why not? So this will be spinning around really quickly. It'll look silly, but I just want to see if it's interfering nicely. Yeah, it kind of is. I still think that the disc is too sharp, perhaps. But anyway, it certainly adds a glow, and we'll run with that for a little bit. I'll put that back to sensible number. In fact, I'll just remove it. So what does the additive mode does? Well, as has just been answered below, yes, indeed. So that adds two decals together, and they will saturate. So normally, when you draw a decal on top of the other, the alpha blending comes into effect, and they blend themselves according to the alpha. Well, with additive blending, instead, they don't blend; they accumulate. With alpha as well, and so this allows you to get these sort of very bright feeling things. If we draw, maybe you missed that early video, if we go back to drawing without setting the decal mode to additive and have a look at really what the difference is. So we're drawing three decals on top of each other here. You see, it looks a bit flat and a bit bland. Doesn't look anywhere near as bright. It doesn't give you that illusion of heat and warmth. There's quite a few follows going on here. I've decided that I do appreciate all the follows, but I'm certainly not going to be reading them all out individually. We spent a lot. I watched the last video, and I kept sort of stopping every 2 minutes to read out more and more follows. So it is thoroughly appreciated. And sorry if I'm not name checking you. Is this an OpenGL or processing? Technically, this is OpenGL. So this is, I'm guessing you might not be familiar with some of my output. I create a tool called the Pixel Game Engine, which is fundamentally an OpenGL tool. Just allows you to play with pixels very simply indeed. You just include the file and it sorts out everything for you on most of the common operating systems. So we've now rendered the star. So what I want to do now is I need to give some sort of impression of scale of the universe. Is bloom like a common additive post-processing effect? Bloom is. And I tell you something. We'll look at bloom in a little bit more detail later on in this series. I've created a PegX, it's a Pixel Game Engine extension, which allows you to leverage the pixel shader capabilities of your GPU. And that's going to be coming out sort of probably the end of spring, something like that. I've got a few more tests I want to run on it first, and that will then allow you to do sort of all sorts of crazy, weird effects, almost for free on your graphics card. And so that's a big difference. The nice thing about it is it doesn't change anything about how the Pixel game engine works. It works with decals and things, but you will have to start thinking about shaders and that sort of. So there's a level of complexity on there, which some people might find a bit challenging to begin with. For others, it'll be second nature. So that should be a lot of fun, I think. Game engines, code as much as you can so others can code as little as possible. Yeah, and there is some truth to that. The actual Pixel game engine header file itself isn't the smallest header file in the world, but the programs that you can create with it are quite small, and they're very effective too. Just going to have a quick slurp. The for free part won't work when you get your hands on the shaders. When VR was coming out, I suggested somebody do a project in OpenGL and got heavily downvoted by the Unity crowd. Well, I don't know the technical ins and outs of Unity and things, but we certainly don't downvote people in one lone coder land. We just don't do that sort of thing. So, right, the next thing I want to do is I want to sort of make the space seem quite large. Now, I'm going to hack that by creating this texture. This is another big texture, and it's deliberately almost featureless. So if I just put a background in, what we've got here is sort of a yellowish aura appearing inside what is just a swirl. Now, when you look at it like this, it looks ridiculous. Right? It just looks silly. I created this using the swirl tool and a couple of the palettes. I think yes, it's just a yellow blob on a blue and purple swirl. And the reason I've done this is to give some background to the space, because right now my space is just black. And it's not very interesting, it's featureless. But I do want the player to have some sort of sense of where they are. And one of the things that they may need, unless they're on the real outer rims of the galaxy, is some visual indication that they're approaching the centre. That might be something useful. If there's no planets, you can't see where the shadows are. If there's no telemetry systems, you can't follow any lines or anything like that. And what I want is, as you approach the centre of the universe, it feels brighter. And so that's what this texture is going to do. We're going to draw this texture right behind our sun, and in fact we're going to draw it behind absolutely everything. And then that should give us some sort of map to follow in our system. The difficulty part here is I've no idea how big to make this, and this is where we're starting to think about scale and shape and size. How long should it take to fly across the surface of the Earth in our example? I'm just going to catch up some of the chats. The only thing I use OpenGL for is loading my fragment shaders and drawing a quad applying the shader. Well, that's exactly what the shading Pegex does. Hey, Ishi's here, that's good. Who else have we got? Virtual boy coding in Turbo Pascal. Oof, Turbo Pascal, lippy neck. Right, so I have this image. I have no idea what it's called. I've forgotten already. It's called space background. So I'm going to draw that in my main game loop. Now, if you're not familiar with the Pixel game engine, sorry to repeat it for those who are, you have a function called onUserUpdate, which is called every single frame, and it's on here that we're drawing our universe. In fact, that's it. We're handling a bit of user input, and we're going through all of the planets and getting them to update themselves, and then we're just drawing all of the planets. It's as simple as that. So I'm going to draw space. I'm going to draw where my sun exists, which is always going to be element 0 in my vector of planets. I'm going to draw this background texture, but I need to load it first. And so, okay, we'll do that. We'll create a renderable. And I'm going to call this one MGFX Cosmic Background Loveliness. There we go. And we'll need to load that, of course. And we'll do that in onUserCreate. So onUserCreate, unlike onUserUpdate, is called once at the start of your program. And we can do load. And we'll pass in assets. That's where all of the stuff is stored. And what did we say it was? Space background. Can't type. Background.png. I'm just going to check that that is actually, what did I call it? Did I call it? Yes, space background.png. Perfect. And then we want to draw that, of course. And we're going to draw that. I'm going to draw it using the rotate decal function for no other reason that it's got a convenient offset in. I'm not actually bothered about rotating it. So we'll draw that here. TV.draw rotated decal. I want to specify where. Well, it's the middle of our universe. Which is where our sun is. I could take the sun's coordinate if we started sort of playing games like that, but it's drawn in the middle of the universe. The decal is GFX, cosmic background loveliness, dot decal. The angle is always going to be 0, and the center is actually going to be 1024.0f, 1024.0f, because our texture here was 2048 squared. And on here, the scale, this is where the thing is going to get interesting, because I have no idea what a sensible scale is really going to be. So I'm going to just pick something stupid to begin with, and when we'll zone it in. Let's have 1000 by 1000. And I'm going to tint it with nothing. It's just going to stay as is. That reminds me, somebody shouted out last time that maybe it was worth it. See, I go back and look at the VODs and I read the chat, so don't worry if you're shouting out and you think I'm missing ideas. I do actually make a note of them. I forgot what I was going to say. It was the star rendering itself that maybe it's worthwhile scaling one of the star skies in the opposite sort of mirroring it. So whereas we scale it here with the size of the sun, actually sticking in a minus here, so that flips it round, and that way you don't have any point in time where they're exactly aligned on top of each other. I can't remember who that was, but I thought it was a good idea when I read through it. Right, just catching up. Not radiation, don't know. We get some. Would you say that Void Star are okay if you specify what the time? I'm always up for some Void Star. I'm not an advocate of super professional modern C++. I just think do what it takes to get the job done. Have you ever written in Lisp? I would be interested in a video series where you talk about different languages and what they brought to the table. I've written a little bit in Lisp, not enough to say that I'm comfortable at all using it. The only time I sort of did any project with it was back in the first year of university, where we had to create something that could play a bit of poker, and we used Lisp for that. And I remember thinking it was an incredibly tedious exercise, and I actually did the whole thing in far less Java. Davey40k, hello. Yes, hello, hope you're doing well. Yeah, well, we're not doing too bad tonight. Cough is a bit better this week, which is a good thing. Expecting some cosmic background radiation. Well, loveliness, right? It's a better word. So, now we've got our loveliness in, let's take a look at it. So, this could be absolutely scaled off the charts. In fact, it could break things. We could run out of floating point precision. There could be all sorts of nonsense going on here. Literally no idea, just stuck a number in it. Right, okay, so we can zoom right out, and we can see space. I think it's probably scaled up just a bit too big. It's also sort of a gloomy yellow colour, and I think that's also because it's a little bit too big. So let's try an order of magnitude smaller, maybe. Yeah, that's not too bad. Got to think of these in terms of game scale. Where are my keys? There we are. You see, if you're flying your ship over here, is there enough information? Can you see the gradient changing enough to know that you're approaching the center of the universe? We can also see that it's slightly blocky. So tell you what, I'm going to use that trick that we discovered last week in the Pixel Game Engine, that I can actually filter this sprite. So we'll just set that to true. That will remove the pixelated... Oh, hang on. Null pointer and then true. An all pointer. So now... Yeah, there we go. You won't be able to see this on the Discord stream. But it's now filtered. Right? You can't make out the individual pixels. can make out some interesting filtering algorithms that it's applied, which is probably interesting in its own right. But it's made a nice sort of banded, gradiented sort of thing towards the center of our system. And it's really nice. I think that's really bright because it actually does brighten up my face. Right, so if I'm on the camera, when I'm near my sun, and when I'm not, and when I am, see, you can actually feel the warmth. It's good. Demo coding. I mean, demo scenes, it's a weird sort of subculture demo scene. I'm never quite sure whether it still really exists or not. It pops up periodically, and you get some sort of certain areas of Europe seem keen on demo scene, but certainly not in and around the UK very much anymore. Is it just me, or is the star not perfectly center in the glow? Ugh. I don't think I can tell. I think it probably is. Maybe it isn't if I do that. Maybe that starts to throw you. It definitely isn't. I think it might be. What do you think? It's too high, too low? Is it up and to the left of it? My perfectionism can confirm it's not. I think it's to the north. Well, okay. The proof is in the pudding here, isn't it? We go and find our yellow dot. I have to try and find the center of the yellow dot. I tell you what, it's not far off because that's 1020 pixels. 21, 22, 23, 24 is there. So that's 24 that way and 24 vertically there. So the hand is right in the middle of this scene. I think it's pretty bob on. Oh, I'm just wondering if we can see the effects of scaling it the other way. It does make the surface of the sun look slightly unfamiliar to me now, at least. We go just have a look at some of the typical hotspots I zoom in on. So we do have a planet potting around here somewhere. What keys did we choose? That was it. There we go. So we have a planet, which now looks a bit strange, sort of with a non-space background behind it, which tells me that our gradient thing is probably still too big. Or our planet is now far too close to the sun. And this is where we have to start making some game decisions. I mean, is it better to have the planet sort of further away, which is a bit more realistic, or is it better to have the planet smaller, perhaps, relative to the size of the sun? Tell you what we can do, though. We should try just taking this down yet another notch. Now, this may look better, but it may have an impact on how we play the game. Right, so that... Well, maybe that's okay. Maybe that's better. Ah, Ericsson catching me out on my dodgy maths again. No, you're quite right. You're right. We should only flip one of those axes. I can't remember who it was that suggested that. Was it you, Ericsson? Let's start. There we go. So now we've made it smaller. I think it actually looks a bit better. Got to remember, we're going to be playing the game at sort of this scale, not ever like this. So even though you've got all of this detail here, it's good for a zoomed out sort of map view of the solar system, but it's not actually that detail for when we're playing the game. But now our planet isn't sort of in that yellow aura anymore. It's starting to look a little bit better. In fact, we created some buttons, didn't we? So we could lock on to the planet. And the planet has a little tiny moon. Well, it should have a little tiny moon. It's just not drawing anything. Ah! It's drawing the purple circle, because we've not yet created sort of a moon object, have we? And here we had another one with its own satellite. There we go. Now, this jittering is this is a byproduct of our camera tracking. And I'm unsure whether, even if we move to the Ericsson smooth camera approach, if that's necessarily going to sort that out. We're also moving very quickly, so in the actual game, time would not be moving this fast. We artificially increase the speed of time to make it interesting whilst we're creating these streams. Ericsson is the math god of the universe. Yeah, right, it looks okay. Are the planets moving on a circular path? No, they are moving on a perfectly circular path. I'm not interested in sort of accurate orbital mechanics. Although I have noticed on the server somebody has been, and they've been implementing actual genuine orbital mechanics using a similar setup. Always good stuff when people sort of take these projects on and continue with their own bit of work to them. So I think as a planet, that's still far too big for our solar system. But I do think the lighting is starting to look okay. So I go into free camera mode. And I need to stop time now, because now is where I want to start thinking about sort of world scales. We've been fixing and bodging numbers everywhere. I want to try and nail this now. So go back to the main part of our program. Here we've got our time. In fact, we need to slow down time quite a considerable amount by the looks of it. So now the universe will look pretty much still, which is no good for our sunspots, because we'll barely see those change, because we were slowing it down for the sunspots anyway. But what I want to try and get a feel for is the sheer scale of the planet. So when we're, see, even at that slow speed, when we're zoomed in to the kind of scale I'm expecting to be playing at, which is something like this, it's going to take us ages to get to the sun, and during this time we've got nothing going on in the background. In fact, even at that scale, see, we can see we're getting closer to the sun because the background is informing us that we're approaching the center. But you know, we should be looking at the sun like this, at this kind of scale. This is inaccurate. Where are the turtles? Oh, we've not got around to rendering the turtles just yet. Put some stars with a touch of parallax effect. Now, stars are interesting. Yes, firstly, Jacob raises an interesting point there. Stars are technically, for all intents and purposes, sorry Ericsson, I know this is going to offend you, but they're infinitely far away. So we're not really going to see much parallax going on. What we will see is space dust and things like that. So maybe that's something useful to add, and that's a typical cheat that they use in this style of game, that if you're flying through the solar system, you've got all of this sort of dust and crud and whatever whizzing past you. And it, you know, obviously they're not stars, but it gives you that impression that you're travelling forwards and sideways, and you need it as a visual cue so you understand what you're doing with your spacecraft. It might be good to have an arrow on the edge of the screen pointing to the sun. I think we'll probably have a more sophisticated telemetry system than just an arrow even. I think we'll actually have sort of paths to the places that you want to visit, because it would be nice to get to a point where we can sort of dial in, well, I want to travel to space station X, whatever, and go there, and it can sort of chart out a course based on fuel and things, and you have to go from planet to planet, and I think there's a lot of scope for doing interesting things here. But for the time being, so I'm toying with the idea, should I add in a quick and dirty hacked little spacecraft with which we can sort of go and explore how these things feel? And get a bit of a feel for the scale of things. So the trouble is, what I don't want to do is sit here for half an hour sort of travelling from one planet to the next during the stream, but maybe during the game, that's actually what you want. We have to give the players something else to do. So it looks like we're getting a few things for our to-do list. Let's start adding some of these down. So we want some sort of space dust to give the illusion of movement. We want stars in the background, I think. Stars, background, which will also help to give the illusion of movement. And we could maybe look at that one next. Of movement. Maybe add hack a spacecraft together and sort of fly about the universe with it. A lens flare type of thing. I don't like lens flares in games because your eyes don't have lens flares. If you accelerate the whole way, it'll be faster than just coasting, but remember to slow down after halfway. You see, that's an interesting dynamic, right? If we wanted to make this a challenge for the player, we could add in things like, well, you've got to slow down somehow, and you know, that's an interesting way of having to navigate around the scene. Nebulas or some kind of giant gas clouds, maybe. Well, Danderstein will know that at some point in the past we did talk about having a ring of asteroids, which was a challenge because there's a lot of space there to fill with stuff. And so we had to think about how do we hack in so many asteroids. I still don't have a solution. So we've also got things like nebulae and giant gas clouds. Giant gas clouds. Hello, good evening from Germany, from Staubfinger Coding Games. Ah, hello. Motion blur for light speed. Now, that's interesting. That could be a candidate for the shaders to sort of start messing around with the scene as we're going in and out of, some warp speed. They can stick their hand out the window to slow down. Okay, Standard Int says, yes, the physics from asteroids would be very cool here. Okay, let's hack in a dirty little spaceship then, because it's simple and easy, and I know that people that are following along with this code may want to start having a bit more of an interaction with it. So we'll do that, and I think the keys we will use for this, if I've not used them already, will just simply be the arrow keys. So this is we're now going off-piste because we have now gone beyond the prototype. That's the interesting bit. So the prototype I made before Christmas stopped at this point. So now we're in uncharted territory, quite literally. Excuse me. So let's create a little asteroids-like spaceship then. Okay. What are we going to need? To begin with, do you know what? I'm not going to create a special object for it just yet. I'm just going to simply hack in, because all we need is the position and the velocity for the thing. So let's have mv craft position. That's its position in space in Cartesian coordinates. And I'm also going to have one for velocity. Nice and simple. Keep this very simple, but it'll give us the opportunity to play with cameras and the opportunity to play with speeds and scales. So maybe worth doing. Maybe it'll get changed and refactored for the end, but right now, worth doing. Right. So, where are we doing this? Let's do this where we're doing user input. So now in space, we don't sort of have drag so much. So I'm not going to do that just yet. But what we are going to have is the velocity. So we'll have turning controls, I think. So you turn left and right, and you have forward and backwards propulsion. Okay, so that's a little bit different. We do actually need some slightly different variables for that. Float, mf craft, heading. We'll call it heading because that's a proper nautical term, isn't it? We'll just initialize that to 0. And we'll also have float mf craft speed. So basically these are our polar coordinates. And by the way, Magetsup, I saw your little static function for doing quick polar to Cartesian coordinates. I like it. I think we'll put that in the next version. Do you want an old sprite I made for a futuristic spacecraft? Yeah, sure. Why not? Bang it in the Discord and we'll see what happens. Just make sure it's appropriate. What about making the static UI look like you're watching from a spaceship? Maybe. Don't know yet. This is all unplanned. We're just making it up as we go along. Right, so if we press the up key, we're going to accelerate. So if get key, we'll see key up dot be held, then we'll have mf. So is that what I called it? Yes, mf craft the speed. Yes, speed is better than velocity in this instance. Plus equals. I don't know. No idea, because I've no idea what the scale of anything is. 10 times... you have to times this by elapsed time, because what we're doing here is integrating sort of the acceleration. So our acceleration is this over time, which is approximate to the nearest frame there. And then we're going to accumulate this into position. So if we're going up, then we increase our speed by 10. If we're going down, we're going to decrease our speed by 10. Now we may have to put a dead zone in there so you can actually stop the craft, or else it'll get quite frustrating. And I've got a feeling that in order to make this playable later, we probably will have to put in some sort of magic space dampening to sort of stop the craft from becoming absolutely uncontrollable, as well as having a max speed for some reason. We also want to be able to turn the ship as well. So if we hold down the left key, mcraft heading, we're going to rotate the craft. What way do we go? So I'm going to get these the wrong way round. Doesn't matter how hard I try. Let's just times the heading by 1. So these are going to be in radians. So that'll be 1 radian per second, which is pretty slow actually. So I'm going to change that to 3 radians per second. Like I say, it doesn't matter which ones I pick, I'm going to get these the wrong way round. And just to stop those going out of control, I'm going to clamp them. mf craft heading. If that is greater than or equal to 2 times 3.14159, so that's greater than 2 pi, then mf craft heading minus equals all of that. And likewise, if we go below 0, we want to wrap round to the other side. Okay. Well, we can see the chat's whizzing by. Sorry if I've missed a few. Key right. Ah, yes, key right. Good point. Community debugging, I like that. So we've sorted out the heading. Did anybody drop a sprite anywhere that I can find? Somebody said they were going to donate a sprite. I can't see it on the Discord, at least nobody's tagged me with it anyway. So right now our ship is going to very much look like, well, I guess we'll have to find something, won't we, that looks like a ship. Where do I have some ships? I do actually have some ships. I have them in eDrive, Lynch, Pixel Game Engines, my old Pixel Game Engine dev thing. There we go, I've got some ships there. So let's pick this one. It's only small, it is a little pixelated. And it's probably 90 degrees the wrong way round. But we'll run with that until somebody comes up with something better. Try to drag and drop on show your stuff, but for some reason it doesn't do anything. Are you green or blue or yellow or pink or what? How are you moving sprites smoothly through a game loop using delta time? Yes, all of the movement happens using what we call f-elapsed time in Pixel Game Engine speak, which is effectively delta time. If you're a green user, just type something in to show your stuff, and I will make you not green. Ah, perfect. There you are. You've just turned blue. You should be able to post some images. Hello, I've been watching your YouTube for a while, but this is my first time catching a stream live. Well, good. The streams are very different to the to our YouTube videos. They're a lot more chaotic, a lot less organised. Right. Okay. So we've been donated a sprite by Vivisector on the Discord, or Mycon here on Twitch. It's a sprite that looks like it's going to need some work to actually get the alpha out of it. So let's pull this open. Open original. So the original sprite was here. Copy image. I just pull this into the art package. File new. Just pick one of these. Doesn't matter what. Control V. Right. So there's the original sprite. Yes, I don't want to show the grid for the time being. There we go. So it has like a native resolution size, and it looks fairly straight, and I think, well, yeah, okay, we can use this. So what we'll do is just magically erase the bits that we don't need. So we can take this. Oh, I need to rasterize this first. A strange thing that Affinity treats images separately to layers of pixels. So I'll rasterize that first. Then that allows me to do sort of selections and things. I'm just going to say transparent background. If we select you and we select you, maybe we can do that a bit smarter. I think we've got, we want to feather this a little bit, don't we? Well, I don't want to spend too much time doing the artwork today, but we've got effectively a sprite like that. Okay. I also want to square this off now. So document. Let's crop. That's the thing I'm looking for. Crop. So I want to get this approximately in the middle. Which is about the. Square this off a bit. Okay, as a quick hack, that's probably good enough. So let's just take that. And now the only problem with this ship, and it's going to be a problem with all of the assets that we bring in, is that the lighting is baked into the ship. Which means as we rotate it, it's not quite going to look right. But, you know, for today, it's a community show. Let's bring it in. So we'll export this as a completed bitmap, PNG file in this case. PNG export space thing, and we'll put Mycon ship 1. There we go. Let's bring back some of the chat. The first time you saw me make not do everything on the first try and make small mistakes. Yeah, well, you know, I'm human. Just make it spin around the upper ring, please. Well, okay, there's, you know, only so much that we're going to be able to do in the remaining time of the stream. It's okay. Well, I've not settled on any assets yet, and I'm doing this. We'll see how it looks, and we'll see how it plays, just to make sure that the ship can actually move around. So we're going to need to pull this in. We'll have to draw it. So let's pull in another renderable, and we'll not give it a big daft name this time. We'll just call it ship. There we go, and we'll load that here. mgfx ship.load assets. What did we call it? Mycon ship1.png. We don't want to filter it because I want to retain the pixel aesthetic, I think, for that. So we want to draw a ship. Now, where are we going to draw the ship? Well, the ship's going to get drawn at its coordinates in space. So we'll draw that after we've drawn everything else. So we draw the whole system. The last thing we're going to draw is the ship. Draw rotated decal again, and we're doing that with our transformed view. And we want MV craft position. That's the position in the whole of space. MGFX ship. Dot decal, and yes, Gorbit, if you're watching, one day I'll put those things in that you keep mithering me for. MF craft heading. That's quite important. It's going to give us the direction, and it might be 90 degrees out. Now the center. Oh, I've no idea how big this actual image is. This is a. Where do I find out? This is 740 by 730. Oh, 740 by 730. Really? Is that what it is? So that's 370 by, what did I say it was? 730? 365. 365. Half those. Right. So that's the center point. Scale, I'm going to leave at 1 by 1. So again, no idea how this is going to pan out. Let's just draw that to begin with. It's going to draw it on the sun, which means we might not even be able to see it. Wow, okay, no, we can definitely see it. It's huge. Why is it so big? That's because relative to our sun sprite, I don't know why that's so big. I'm trying to work that out. Have I accidentally not put the offset in? Have I put that as the scale? Well, regardless, we'll make it very small. Make it 1,000 times smaller. That's actually beneficial for us, because if we start going larger with numbers, we're going to end up in this horrible area where our floating point isn't accurate enough for the small and the big numbers that we're going to be using. Right, that looks a bit better. So there is our craft. Right, relative oomph, to the sun. Yes, I like that. That's about right. Ship it. Well, it's not a small ship. It's a huge ship. This ship is like, you know, it's as big as the UK. It's just the sun's much bigger. Right. So let's make our ship move about a bit. The sun's going to melt. We also need to think about how do we make the craft as it flies in front of the sun. Does it black out to give you that illusion of brightness, to foster it a bit more? Draw rotated decal. Oh, we actually put in controls, didn't we? We just need to actually implement what this does. So once we've got a heading, we want to set our velocity vector. So our velocity, mv craft velocity, is simply what we've done before, but I'm going to do it in one line here, is mf craft speed times the cosine of our angle, which is heading, craft heading, in the x-axis. And we'll also do the same in the y-axis. So we're just basically converting this polar coordinate to Cartesian here. So that's our velocity vector. And therefore we can augment our position with our velocity vector. Craft velocity, mv craft velocity. We've got to modulate that as well by f elapsed time, and that's quite an important thing to do, because we used this multiplication with time to turn our acceleration constant into velocity, and here we're multiplying that velocity by time to turn that into a change in position. So that, if you remember back to your high school mechanics, you end up with ut plus half at squared. Well, that's where our t squared component comes into it. We have these two f elapsed times multiplying with each other before it yields the final position point in space. Hey, Tessa. Right, so no idea how. I imagine it's barely going to move the ship. We're not even going to perceive it moving. It's going to be so slow, but we'll have a look. Right, so left and right changed the heading of the craft. And oh yes, I said it might be out by 90 degrees. It is out by 90 degrees. That's quite confusing. And also the camera, the camera doesn't necessarily follow the craft. Oh dear, it's speeding up because I keep pressing the wrong button. Let's slow it down. Oh, now we're going backwards. Right, hang on. So I think if I just disable the locked on mouse, there we are. Okay, so for some reason the craft is travelling sideways. That's because our graphic was pointing down. Now when you create graphics for games, one of the things you might want to remember is that the 0 angle is actually along the x-axis and not down like that. So that's why I thought there might be... Oh, I've lost the ship. That's why I thought there might be a 90-degree discrepancy. Anyway, let's speed up quite a bit. And I like the scale's not bad, right? It's going to take ages to get across the surface of the sun. That's what we want. Right, slow it down a little bit so I can keep up with it. Because I don't think I'm going... How far? Right, so it's that little white dot there, which is probably not coming through on the stream, is our craft. And our planet is, well, quite a way away. Oh, no. I've lost the ship. There it is. Right, so our SS Plabnet is doing just fine. So I want to make the camera look at the ship, I think. So that should be one of our options. So we had our free camera mode, which was done with the tab button. How did I implement that? So selected planet was -1. I now want a sort of follow the ship mode. That's slightly different because we're not selecting a planet in this instance. So I'm going to map that onto key F1 just for the time being, whilst we're debugging these sort of things. So that way I can always find the ship. So when we press F1, I'm going to set my selected planet. I'm going to hack this to -2. I'll put in a specific clause here that if we have a selected planet of -2, then we will tie our camera to that. So this is a dirty hack. We need all of that again. Sorry, I'm just pausing there because I'm wondering if one of the reasons it didn't look quite central is because I'm setting the camera position after I've drawn the rotated decal. I don't think you'd notice it. That would only be a 1 frame difference. This is a little bit slack, that. So I think instead what we should do is just move these lines down to here. At least that way our drawing is consistent with our camera position. Right, now we're following in this instance just our craft position. MV craft pos, and we don't necessarily need this this latency thing that we had last time. We'll just keep it sort of rigid and in place. So actually this makes this much simpler. It's just MV craft pos there. There is no camera coordinates, is there? MV craft pos. We'll just leave that later on, because if we do end up playing with a different camera function, maybe that's what we want it to look like. Right, so let's try that. So it doesn't matter what speed I am now. If I press the F1 key, the camera should be tied to the position of the ship. So if I just start accelerating a little bit and press F1, there we go. So the ship's always now in the middle of the screen. It's a bit confusing that it's 90 degrees out. But it doesn't matter what my zoom level is now. Let's accelerate towards the planet. Whoa, whoa, whoa. Slow down, slow down, slow down, slow down. Oh, I think I slowed down too much, but the ship was facing the wrong way. So it was swing right. Slow down, slow down, slow down, slow down. Alright, speed up then. No, slow down. Right, having the ship at 90 degrees is not a good thing. So let's sort that out first. No idea where I'm going. Where's the best way to? We just need to draw it in the right location. So we've got our craft heading. Let's just take 3.14159 f divided by 2. What's that in there? Oh, my pi's wrong. Oh. Ah, yes, press the wrong keys. I'm pressing W, S, A, and D, which we've mapped onto moving between planets. Right, okay. Camera mode is in follow. The craft is now... It is turning the wrong way now. Let's just fix that up. So we got our left and right the wrong way round. You're always going to get that the wrong way round. It doesn't matter how many times you've done something like this, you'll always get that the wrong way round. Right, F1. Yes, that's good. The ship is now turning in the right place. Let's go and find the planet. Got to go very quickly. Start to slow us down. Zoom back in. I'm concentrating here. This is hard. Slow us down a bit more. There we go. Right. So you see, I think the planet is not big enough compared to the size of our ship. Oh, oh. Something strange going on with backward movement here. Ah, do you know what the thing is? The problem is the physics are rubbish. I should be able to turn the ship, but it should keep going in the same direction. So right now, really, what we've got is this car that drives around in space. rather than a spacecraft. And that's what was confusing me. I was thinking, oh, why is this why is it getting so fast and that sort of thing. So yeah, okay, we've built a sort of space car. Yeah, it's got, with perfect traction in space. It's just brilliant. Why is that? That's because we're just setting, I think. We got our velocity here. That should be plus equals our craft speed and the heading. I'm just wondering, do we need to... Yes, so that now actually does change. So that F elapsed time is necessary here, because that's become our acceleration constant. Yeah, so that we need to wrap that up in a vector. Multiply u by F elapsed time. But this F elapsed time here, where we're changing the speed... Don't know. Getting confused. Let's have a go. Just see what happens. Hack it out. Oh, follow the craft. Now, as I turn the craft... Yeah, so I've not put any thrust. I quite like that movement. I've no idea what that movement actually is, but it's still not right. But the idea is now I can turn the craft, and we still keep going in the same direction. Now, if I'm facing that way, and I'm applying thrust, there we go. So now we're thrusting, and now we'll thrust in this direction. Yeah, it does work. But as you can see, we're going ridiculously quickly now. And that's because of this accumulation of velocities and accelerations. That's not right. But rather awkwardly for me, and probably for you guys as well, we've actually reached the end of the stream for today. Which is a terrible shame, isn't it? Hasn't it gone quick today? I like doing these code zones, and I'm thinking of maybe going to 2 code zones a week, but Not promising anything yet. Let me know how you feel about that. Thank you for all of those that have joined in. Thank you for all those who have followed. Thank you for Mycon for the sprite. We'll have a little bit of a chat on the Discord afterwards. I hope it's been silly and enjoyable. I may be putting a video out on YouTube this weekend, so I might be quite busy over the weekend. I should leave these running whilst I'm talking about stuff, shouldn't I? Yeah, keep the sun running so we know what's going on. I have nowhere to send you, but thank you all for coming along, and I will see you on the CodeZone next week. Take care.